I've got x equals 0.9 recurring. Now look at this. There's going to be billions of 9s going in that direction right across off the screen and off into your bedroom wherever you're watching this video. So x is that. So watch this. 10x is going to be 9.9 recurring with billions of 9s there. 10x take away 1x is 9x. 9.9 recurring take away 0.9 recurring is going to be exactly 9. So guess what? X equals 1. Does that make sense? Yes, it does. If I've got 0.9 recurring, I've got so many 9s here, you could spend your whole lifetime writing them in, and you get so close to 1, all these are 9s by the way, not A's, you get so close to 1 that you may as well call it 1. So employing this technique here shows that 0.9 recurring towards infinity and beyond, Buzz Lightyear, that's like saying, well, that's just call it 1 and call it quits. Alright, so that's that. I fancy the next one as well. I've got to do that. Let's see what I'm letting myself in for. Right, let x equal 0.315 and it recurs from there to there. Alright, the book says 315, 315. I'm not going to write all that rubbish out. Now look, 3 figures, let's go for 1,000 x's. And that will give us 315.315. Look, that matches that exactly, and that carries on recurring. So I can say to myself, if I subtract 1x from 1,000x, that goes from that, and I'm left with 999 x's equals 315, and x will be 315 all over 999. Well, I can see 3 going into that quite nicely. Try and simplify it with that calculator. Let's do the easy bit. 3 goes into 999, it's called 333. I can see 3 goes into 300 100 times, 3 goes into 15 5 times, so I've got 105. What else? 3 goes further into that, 3 goes into there 111, and 335 is 105. Anything else? Could you put anything else in that? 5s, 7s? I'm going to stop. So I'm going to say basically that 0.315 recurring between the 3 and the 5 is 35 over 11. I'm going to stop right there. I'm going to make some up. I just really fancy making some up. I don't think there's enough practice in this book, honestly, so maybe add a few more pages and do some made up ones. If I get stuck, you know, forgive me. I'm really trying to give you some more practice here. So let's go to for serious dark black. Right, I'm going to let x equal to 0.45 and it recurs there and there. I don't know what's going to happen, I just want to do it. So 100x now. Sorry, let x equal that. So 100 x's should clear the fence quite nicely. 45.45 recurring there and there. So that take away that. I've got 99 x's equals to 45 exactly because they disappear. That's quite easy actually. I chose a nice one. 45 over 99. What have I got here? 5 goes in there, 3 goes in there. Yeah, 3 goes into 99 33 times. 3 goes in there 15 times. Try and go further really. Yep. 3 goes in there 5 times. 3 goes in there 11 times. Oh, I'm loving it. It's a real beaut. Let's try this one then. If I crash, forgive me, and we'll call this a real pain. Try this. Let x equal 0.16 recurring. Now look, this is a dodgy one. There isn't an example of this in the book at all, but I'm going to do it. That means 0.166666666666666666. Okay, so you don't go 161616. You go 0.166666. Loads of sixes. All right. Now, usual trick. 100 x's just to clear the fence. Doing, doing. 16.16 recurring. Have you got that? Once, twice. Sorry, I lied. I made a mistake. 16.6 recurring. So the 6 is going. But look, the 1.6 recurring doesn't line up with just the 0.6 recurring. So I've got to manipulate this so as to get these 6's to match. Look what happens if I multiply by 10. If I multiply 0.16 by 10, I get 1.6 recurring, and look what I've achieved. This 0.6 exactly matches that 0.6 in the first decimal place. Right, now how did I do that? Well, 100x take away 10x is 90 x's. 16 take away 1 is 15. So I've got 90x equals 15. X equals 15 over 90. Let's go to black now. I can simplify that further. 3 lives in there. Let's see, have a look. 3 lives in there 5 times. 3 lives in there 30 times. I'm sure I can go further with that one. 1/6. Yes, that is lovely. Put a little yellow box around that one. Again, there's not an example of this in the AQA book at all, but I felt I ought to show you that, really, and you can study that. So when these things recur, they may not recur straight after the decimal point. It may recur further along. So you might get things like 0.2733333333, and then you just do the best job you can with that. But I'm going to stop there because I've gone beyond the scope of the book and probably beyond the scope of this new GCSE syllabus. So I'm going to stop right there, and you can study it.